In this blog I'm going to show you how to design and simulate an 8-bit CPU in logician. So if you're interested in following the blog, click on the link down below the video. So first of all, we're going to look at the idea of computer and computer time. So if we had a machine that can do 3 or 4 billion things for us every second, what would that mean to us in terms of our human time scales, and what would we be able to do with such a machine? So this goes through the idea of looking at geological time, human time, and also computer time, because it's only in the last 30 years or so that we've had access to machines that can work at really billions of can do billions of things every second. So that's a nice little lead in and introduction. We then go on and we'll look at the actual architecture of our CPU. So we're going to have a random access memory, we're going to have a memory address register, we're going to have 4 registers here, there's going to be an ALU, an accumulator, and a clock, and a control unit, and there's a few other little sundry items here as well. So the first part, we're going to talk through the RAM, the accumulator, the temporary register, the ALU, and then we're going to go on and create our first, what I would call assembly language, or a pseudo assembly language program. So this program here allows us to add 2 numbers together. So it really shows us how we're able to control all of the sets and the enables in order to pass the information round about the CPU that allow us to go and add 2 numbers. We then go on and we'll look at the clock, and we can see how we're able to pass information round about the CPU using the clock. So in this example here, we pass information from one register to another register. We then go on to the most interesting part of the design, which is the control unit. So the control unit is going to control all of the sets enables in a particular manner in order to allow us to do something useful with the CPU. So we start off with looking at one instruction, which is to add 2 numbers together. So this instruction here is going to be coded into our control unit, and it's going to be hardwired, and this shows the hardwiring that will allow us to add those 2 numbers together. We then look at the idea of creating more assembly language code and creating mnemonics from our machine code in order to create a whole language here that we can use in order to program the CPU. So the first mnemonic we have is the add R1 R0, so that's our first assembly language instruction. And what we have here is a description of how this instruction has actually been created. We then have a quick look at the instruction set for the entire CPU. So this is every single instruction that we create that can be run on our CPU. We then go ahead and look at some code snippets. So these are actual snippets of code that will run live on the CPU. So we look at dividing 2 numbers, subtracting 2 numbers, and also creating the Fibonacci series. We then go ahead and we see how we can build an assembler in Microsoft Excel. And then what we do is we simulate the entire CPU within Excel VBA. So this simulation of the entire CPU allows us to create a debugger. So this is going to allow us to write and test our assembly language code actually in Excel before we go and load it into the actual CPU. So what we have here is the actual code here, which is in the white columns, and in the green columns here is the values for the instruction address register, the instruction register, all other registers, and also the flags as well. So this works through the CPU assembly language code one line at a time, and it allows us to debug the code, and allows us to create more efficient code, and allows us to create the code a lot quicker. So finally, we're going to have a look at the actual design here in logician. So you can see here that we have our RAM, our memory address register, we've got our other registers here, we've got our ALU, the accumulator, and we've got our clock here. We've also got another couple of registers, which are the instruction address register and the instruction register, and there's a few other sundry items here that I had to add in order to get it to function properly within Logisim. And this is the ALU design here. So we've got an adder, we've got a shift right, shift left, not and or, and we've got a comparator. And this is the RAM, so it's a 256 byte RAM, so it's a 16 by 16 construction. So that looks really complicated, but it isn't really. It's just that there's an awful lot. It's just a big circuit. And finally, this is the control unit here. So that's the final version of the control unit. Now, the CPU is not much use to us unless we can actually load some programs into it and we can get some output from it. So I've got a top level simulation here. So this is the top level, and we've got our CPU here. We've got an external RAM, so we're going to use this in order to load our program into the CPU. And I've taken copies of the values on the bus and the accumulator and the instruction address register, the instruction register, and the 4 registers. So this helps us to look and see what the output of the CPU is. And we've also got some functions in here we use in order to control the whole simulation. So the final simulation, what we're going to do is we're going to write our program in assembly language. We're going to test it in the debugger. So once we've got it working in the debugger, we're then going to take it and we can output it using our assembler. That will create an executable file, and then we can take the executable file, we can load it into our CPU, and then we can run it on the CPU, and we can see and check the output and make sure that the CPU actually does what we've programmed it to do. And you can see this all happening in front of your eyes. You can see it running live. So finally, if you're interested in taking the entire course, you can click on the button here, and it will take you through to the course itself. So the course has got 39 video lectures over 9 hours, and it gives you access to all of the simulations. So you can go and download the simulations, and you can build the whole entire CPU up yourself. And once you get up and running, you can start writing some script or writing some assembly language code to run in it yourself. So that's all there is. It's an interesting course. I really enjoyed putting it together, and I hope you like it. So catch you later. Goodbye.